Hello, everyone. Don Yillis from Emerson. I'm going to be discussing compressor modulation today with you. It's a two-part series. We're going to talk about two-stage, variable, tandems and trios, and also going to get into the digital side of things, okay? So bear with me. Let me take time here to pull my screen up, share it with you. I'm working alone, so hopefully you can see that. Okay. Again, I'm Don Gillis with Emerson. This is going to be our virtual classroom. We're going to be talking about capacity modulation today. All right. And a little bit about myself. Again, I'm Don. Joined Emerson in July of 2017. Have approximately 28 years of experience, roughly. I've been an installer, a service technician, a service manager. Obviously, I've done some tech support, and I am a full-time HVACR instructor for Emerson. I am a licensed journeyman. I've served on the heating advisory board for Ivy Tech Community College. I now sit on UNOH heating advisory, also on High Point in Bellefontaine, Ohio, and so on and so forth. Most of you probably know, if you're instructors, I've spoke at RSES National Conference a couple times, and as we're doing right now, the HVAC Educators also I've done a couple times in Vegas, okay? I am a judge at Skills USA National for the last 3 years, and then my credentials of what I've attended and the different schools I went to are at the bottom there, okay? So enough about me. Let's get into our modulation. Learning objectives today are going to be, after completing this session, you'll be able to describe the operation, functionality, and benefits of compressor modulation methods, including two-stage, multiples, digital, and variable speed. And we're going to explain how to perform a scroll or discus digital upgrade. And we've got some videos for you on that also. Okay. Talk about a few things here. This really doesn't have anything to do with the presentation, but I would like you in your spare time. This is something I normally do before the class starts, is have you download these apps. I would focus in specifically, if nothing else, make sure you download the Copeland Mobile, okay? Really, really cool stuff. Put your first 4 characters of any compressor, our compressor, and our competitor's compressor, and it'll pop up, as long as it's not outdated, okay? And when I say outdated, from what I understand, they've dumped all the information in as far back as 1981, I believe. So for the most part, you'll find almost everything on there, but I'm not going to mislead you. I have had compressors that did not come up. I've found compressors, I do a lot of teardowns, compressors from 1964 with no barcode on them, and not that matters about the barcode, but some things will not come up, okay? Another PT Pro, just a PT chart, digital, and then our AE bulletins, which basically tells you everything you want to know about any Emerson or any Copeland product, anything out there. It will show you, tell you how the engineers feel about a certain application, whether it's something as simple as, you know, what does an accumulator do or anything like that, and how we feel about that. How do we feel about vacuum pumps, pumping down a system, and so on and so forth. You may even see some AE bulletins on these slides today, okay? So capacity modulation. We're going to talk about capacity modulation with scroll compressors. The first thing I want to do, though, I think it's important to understand how a scroll compressor works, actually. Just for lack of better terms, the anatomy of the scroll, okay? Most of you might already know this. The students may not, okay? Some of you instructors, if not all of you, probably already know where I'm headed with this, but I think it's important to point out just a few things about the scroll that I think will make better sense when we get into the modulation part, when I start using some terminology, all right? So without further ado, let's get into this. Settings. Systems. Okay. Okay, back to here. Let's talk about this real quick. Again, I just want to touch a little bit on the scroll compressor. We're stating over here, we have the, let me see. Okay, very good. Well, we got this here. Okay, now we're ready to go, Alex. Okay, here's a cutaway of a scroll compressor. Touch on some of the terminology. Anything below this muffler plate, Okay, this muffler plate, which is painted in blue here, everything below that is low suction pressure. Okay, the scroll is refrigerant cooled. In fact, most all of our compressors are refrigerant cooled. All right, so anything below that, we're referring to that as low suction pressure. Anything above that plate as it discharges through the scroll set is going to be high pressure. All right, high discharge pressure. Talk a little bit about the mechanics, compression, and radial compliance. The radial compliance is going to be side to side, and I'll touch a little bit on that to show you how that works. Pressure balancing, and more importantly, the axial compliance is what I really want to show you, especially when we get into digital and those things, because I want to show you how that works, not just with the fixed scroll, but how it comes into play on our modulation compressors also. And then we've got high side pressure, everything above that blue plate, okay, that muffler plate, and then internal pressure relief and TOD and lubrication. All right, let's talk about this. That's not going to work, Alex. That's not going to work. Here's where we need to pick it up at, Alex. Okay. Oh boy. All right, here we go. Let's talk about the scroll set itself. So on the left-hand side, we have the orbiting scroll. That's the movement scroll. It's at the bottom. You'll notice these little notches out of there on the scroll set. Okay, that's where our Oldham coupling is going to sit in. I've got a couple here for you that I was going to show you also. So here's our orbiting scroll, and here is our fixed scroll, which is on your right. Okay. All right, so just so you know, I'm not going to go into all the details about the scroll set because this is about modulation, but I do want you to understand some of the moving parts in here. I think it's important for us to have this conversation prior to getting into modulation, okay? The very top of this is your tips, the sides is your flanks. This is the Oldham coupling, and the Oldham coupling, moving back here, is what keeps this aligned, all right? These notches, all right? And let's say this is the orbiting scroll on these two pegs. This is the fixed scroll on these two pegs. And it basically, not basically, it keeps it from going out of alignment. I'll show you, put this together here a little bit. See if I can get this together for you. There we go. And there we are. Okay, so that's how it looks. I've got the Oldham coupling on these scroll sets, and it's going to go in like this, move around, and compress that gas along those flanks on the side. All right. This is what we call radial compliance, and radial compliance is, to me, is just as simple as saying we're horizontal movement, okay, side to side, and what allows it to the scroll set to tolerate if you were to get a liquid droplet, if you will. Okay, there's a piece of Swedish steel right here inside this bushing. It almost looks like the letter D. Okay, and that allows it, as you can tell by the arrows, to move left or right. So it almost acts as a spring, if you will. So it's much more tolerant than, let's say, a reciprocating compressor is. It doesn't mean it will take liquid refrigerant, by no means, but it does help tolerate it quite a bit if if in fact it gets inside there. So on the left-hand side, we have axial compliance. Now, axial compliance, and I usually typically ask the class to write this down. This is heavily exaggerated. We're looking more at like 1 millimeter to movement up and down. Axial will be up and down, your vertical movement. This is the radial compliance where I showed you that piece of Swedish steel earlier. This is real important to understand this, and this is why I wanted to talk a little bit about the moving parts and just the basic fixed scroll before we get into modulation. The scroll starts out unloaded, okay? It's a 2-pole motor, runs at 3,500 RPMs, roughly nominal, okay? When it starts to load up, as the gas starts to get in, the contactor pulls in, we have a little bleed port here. And as this starts to pressurize on the scroll, the way this floating seal works, this is a large one on the top of it, and it sits right there on top of that fixed scroll I showed you earlier. The bleed port allows gas to get in that cavity. This is normally sitting on that ledge there. And what happens is 2 things are going on there. It pressurizes that cavity, causing this floating seal to push up on the muffler cap, but it also allows the fixed scroll to go down with the tips of both scrolls touching, okay? That pressurizes that and pushes that 1 millimeter. It's important to know that 1 millimeter because, again, that's going to come into play in our modulation. This is just a better look at the floating seal. Here you're looking at the left-hand side, you're looking at the floating seal setting down inside that fixed scroll. Right down, looking at the top of it. Here's what that floating seal looks like. This plays an important part because it separates that gas, as we talked about earlier. When this pushes up to that muffler plate, it doesn't allow that discharge gas to go over the top of it. So it isolates it, forcing it to go out the top above that muffler plate and at the top of the scroll compressor. If this were to fall down, and I'll get into that later on, okay, this gas would then come around and re-enter that suction gas with the motor. Over here is what we call sleeve guides on the right-hand side. That is allowing that 1 millimeter separation when we load and unload, when we get into digital. When I refer to that 1 millimeter on that sleeve guides, this is what I'm talking about, all right? And we'll get more into that as we move along. This is just showing you a check valve. Most all compressors or scroll compressors have check valves in them. They range from anything from inside the discharge line as it moves out, leaving the compressor, to in dead center, right in the heart of the compressor at the hottest point of the compressor in the discharge port. Some may have 2. And that's it for just the basic anatomy of the scroll. And now we'll get into the modulation section of it. All right, we'll start with the capacity modulation as we talked. Oh, no, I don't want to do that. It's not what I want to do. All right, Alex, this is where I want to pick up at on this, okay? It's kind of difficult trying to understand, walk through all this stuff by myself. Try to get rid of all this stuff that I don't need. Okay. Okay, again, Alex, this is where we're going to pick up at on this. All right. So let's get into capacity modulation. We're going to start out with some scroll. Up in the left-hand corner there at the top, we'll start from left to right at the top. We're going to talk about two-stage mechanical modulation. Two-stage, I try to keep everything really simple, is full capacity, obviously 100%, like a fixed scroll would be. If it's sorry, Alex. I don't have everything turned off, I guess, yet. You're really going to have to edit the heck out of this. I apologize. Okay, we'll talk about capacity control modulation methods. On the left-hand side, at the top, we have two-stage modulation. And again, as I was talking about earlier, at 100%, like a fixed scroll, that will be our second stage. Our first stage is going to be about 2/3 of the capacity, 67% of the capacity. And I'll show you what that looks like with some scroll sets I have laying here. Variable speed, that's going to be